All right, guys, sorry I'm out today, but here are your notes for 12.4, standard deviation. Standard deviation is the measure of how much the values in the data set vary from the mean. So it's going to tell us how much things are set apart from each other. It's often represented by the Greek letter sigma. It looks like an O with a hat on top. It is sigma. We had talked about capital sigma earlier. Capital sigma looks like that. But the one we want today looks like this. And the way we find standard deviation, you have to do 5 steps to do it. The first step is find the mean. Find the mean. Remember yesterday we said it was X bar. Find the mean of the data. And then the next we have to do is find the difference. Find the difference between data and mean. And we're going to do this in the table down below. I already have our data and I have our steps in here. And then the next thing we're going to do is we're going to take that difference and square it. So square the difference. And then we had to find the averages of the squares. Find the averages of the squares. Find the averages of the squares. So we're going to take all of our averages from all of the differences and find them out. And then the last thing we have to do is take the square root to find our standard deviation. So here we go. We're going to do all of these steps and we're going to figure them out. So let's see, we're going to do 5 numbers here. So the first thing I have to do is find the average. So I got to do 48 plus 53.2 plus 52.3 plus 46.6 plus 49.9. Then I got to divide it by 5. And if we do this, we're going to figure out that the average, or X bar, is equal to 50. So I'm going to use that. I'm going to plug it into this table right here. So our mean is 50. So 50, 50, 50, 50, 50. And then in the next spot, all right, so I found my mean. Now I got to find the difference. So I got to take my number and minus the mean. So if I do that, 48 minus 50 is negative 2. 53.2 minus 50 is 3.2. And then I would get 2.3. And then negative 3.4. And then negative 0.1. And then I have to square the number. So I have to take negative 2 times negative 2. 3.2 times 3.2 is 10.24, and then 2.3 times 2.3 is 5.29. Negative 3.4 times negative 3.4, 11.56. Negative 0.1 times negative 0.1 is 0.01. All right, so I've squared the differences. Now I have to find the averages of my squares. So I'm going to add up all of these. If I add them all up, I get 31.1, but then I have to find the average, so I'm going to divide it by 5, and then whatever this comes out to be is, let's see, 31.1 divided by 5, 6.22. All right, so I found the averages of the squares. Now I have to take the square root. The square root of 6.22 is 2.5. So 2.5 is my standard deviation. Woo! That is a lot of work to do by hand, and that is terrible. So what we're going to do is we're going to use our calculators to help us out here. So what I'm going to do is I'm going to do the same thing that we did yesterday. It says find the mean and standard deviation for the heights of our boys and girls basketball team. So all of these numbers are in inches. So what I'm going to do is I'm going to take my calculator out. I'm going to go back to stat. I'm going to edit. And then if you have a calculator like mine and you have a bunch of numbers in there, to clear things out, go up to L1, hit clear, and then enter. And now we can start typing in our numbers. So I'm going to pause the video while I type in my numbers. You do the same. All right, I have all of my numbers in here now. So all I'm going to do is I'm going to do the same thing as yesterday. I'm going to hit stat again. I'm going to go over to edit, one variable stats, hit enter. And now the numbers we're looking for. So if I have to find the mean and the standard deviation, all I'm going to do is say, well, my mean is X bar, and X bar is the very first one. So it looks like our average height is 68 inches. Now I want to figure out what is our standard deviation. So my standard deviation is right here. So you see how there's this little sigma sign with the O with the hat on top? I'm looking for this number right here. So I'm going to go to the nearest tenth. So I'm going to call this 5.2 inches. All right. And now I'm going to do the same thing for these two tests right here. So I want you guys to pick one of them or both of them. You can try them. I'm going to pause mine so I can type in the answers or type in the numbers, and then you guys can check your answers. All right, these are the averages, the means. So what does this mean? So if my average is 66.3 and I went up one standard deviation, all I have to do is add 14%. So if I went up plus one standard deviation, I would be at 80.3%. And then if I went another standard deviation, I would add another 14. I would be at 94.3%. And then if I went another one, I would be at 108.3%. I could also do the same thing going down. So if I went down one standard deviation, 66.3 minus 14 is 52.3. And then I could go down another one. I would be at 38.3. And then if I went down one more, I would be at 24.3%. And we are going to use these to help us figure out how data is going to lie. So I'm going to pause it while I flip over the page. I hope you do the same. Last thing we're going to learn about is a thing called z-scores, and a z-score will tell you exactly how many standard deviations a data point is away from the mean. And it's actually got a really easy equation for it. So the formula for z-scores is the z-score is equal to whatever number we got. So whatever value it is minus the mean divided by the standard deviation. So I'm going to still use the same scores that we had from the last test from the previous page. So if you didn't do those, the average was 66.3%. The standard deviation was, we'll call it 14. All right.